TorchStudio can be used both as a standalone software or as an extension to your favorite IDE. Visual Studio Code, PyCharm, Spider, and Sublime Text are currently supported. This video will focus on PyCharm, but the workflow is basically the same for the other IDEs. First things first, we'll start by installing the extensions. Launch TorchStudio and go to Menu Settings. Install the required IDE extensions and close TorchStudio. Then let's open the IDE and our machine learning project. To add TorchStudio to your project, right-click on your project folder and click New TorchStudio Training. This will add a TorchStudio training.tsz file to your project. Open that file to open the TorchStudio session corresponding to your project. Notice that the TorchStudio window that opens is pinned at the top of all other windows. This allows us easy drag and drop between the IDE and TorchStudio. You can unpin that window if needed. Let's start by defining a dataset. We can use one of the datasets that comes with TorchStudio and the PyTorch ecosystem, or use your own dataset. In this case, our machine learning project already defines a dataset. All I have to do is drag and drop it from my IDE project to the TorchStudio window and click Load. This allows me to explore the dataset, reformat it, and analyze it if needed. Then we'll need a model. Let's click the plus icon at the top to create a model tab. Again, we can use models provided by TorchStudio or the PyTorch ecosystem, or our own model. Our machine learning project already provides a model, so let's drag and drop it from the IDE to the TorchStudio window and click Build. This will display its graph representation. We can then define hyperparameters, or let the one that TorchStudio defined automatically, set a training device, and click Train. As we're not sure about the best hyperparameters, let's make a copy of that model by clicking the plus sign at the top and change our default depth value here. Then build it and click Train to queue that training. When the training completes, we can compare both models' performance by going to the Dashboard tab. In this case, we'll choose this model. Then click Menu, Export Model. We can export our model in different formats. As a Python script without the weight, or just the weight, or as a torch script or an NX file containing both the model definition and its weight. In this case, I'm just going to export the weight. Once exported, the weight will be immediately available in the IDE. All I need to complete the project at this point is create the corresponding model and load its weight. It's then ready for inference. Please visit torchstudio.ai if you want to know more.